All right, this video is about graphing a system of inequalities. So essentially what we have here are two inequalities that we want to place on the same coordinate plane and find where their solution regions are intersecting. So a couple different things to talk about here. This first equation is in standard form. And so if it's in standard form, I'm going to take the process of just finding the x and y intercepts. So if I plug 0 in for x, 2 times 0 is 0. And so this term is essentially gone. Okay, so how would I solve the equation 4y equals negative 12? Well, I would divide by 4. So negative 12 divided by 4 is negative 3. All right, and then I'm going to find the opposite one. So I'm going to plug 0 in for y. Well, 4 times 0 again is 0. So really the equation I have to solve is 2x equals negative 12. So to get x alone, I would divide by 2. And negative 12 divided by 2 is negative 6. All right, so what I'm going to do is I'm going to plot those points, and then I'm going to draw a line connecting them. All right, so 0, negative 3. So I'm going to go 0, negative 3. That would be here. And then negative 6, 0. So 1, 2, 3, 4, 5, 6. Okay, if you wanted to create more points than this, I could just count the slope, which is up 3 over 6, and I could continue that pattern. So I could go up 3, left 6, up 3, left 6, if I wanted to continue that slope. All right, this is going to be a solid line since it is less than or equal to. So I'm just going to take my 2 points and connect them with a solid line. Okay. Then I need to figure out where I'm going to shade. So am I going to shade up here or am I going to shade down here? So what I'm going to do to figure that out is I'm going to take a point and I'm going to plug it into the original inequality and see if it is a solution or not. So since 0, 0 is not a part of my boundary line, I'm going to check 0, 0. So that would be 2 times 0 plus 4 times 0 is less than or equal to negative 12. Well, both of these are 0, so is 0 less than or equal to negative 12? I would say that that is an untrue statement. So 0, 0 did not create a correct solution, which means no points on the side of 0, 0 are going to be solutions. So that means my solution region is on the other side of the line. And so I'm going to shade below my line. Okay. My next equation is in slope-intercept form, and so for that one, I'm just gonna plot the y-intercept and then graph the slope accordingly. So the slope 1 over 2. All right, this is my vertical movement, and this is my horizontal movement, and then this is my starting point on the y-axis. So 0, negative 3. Okay. So 0, negative 3, it looks like we're starting at that same point there. And then a slope of 1/2 means up 1 over 2, up 1 over 2. And then I could also reverse it in the other direction by going down 1, left 2, down 1, left 2, and continuing that process. Okay. Now this equation is going to be graphed with a dashed line since it is just greater than. So I'm going to take my line and just create a dashed line. Okay, and then now I have to figure out where I'm going to shade. So am I going to shade up here or am I going to shade down here? So again, I like to use 0, 0, especially if it's not, if it's available. Obviously, if your line is going through 0, 0, you have to choose a different point. So I'm going to take 0, 0 and I'm going to plug it into the original inequality. So that would be 0 is greater than 1/2 times 0 minus 3. So 0 is greater than negative 3. This is a true statement. So that means that anything towards 0, 0 will also make a true statement. So I'm going to shade in that direction. Okay, and so hopefully you can tell that this region right here is where my shading is overlapping, okay? So you can see that the green is shaded there, and then you can see that the red is also shaded there, okay? So looking at this, I can tell that this is the solution region because that is where both colors are intersecting, all right? So any points within this region and continuing on would be solutions to the inequality.